Welcome everyone to today's webinar. We are about to get started. Before we hand it over to our presenters, just a couple of logistics. This webinar will be recorded and we will share the recording with everyone that registered. If you have any questions throughout the presentation, submit them in the Q&A section at the bottom of your screen. And we will be sharing the recording and the slides with you after the fact. And now I will hand it over to Ravi, who will kick us off.
Thank you, Anadelia, and good morning, good afternoon to all the colleagues joining from all over the world into this webinar, which is on the topic of smart data to smart decisions, the power of digital twins. I'm Ravi Subramanyan. I'm happy to welcome you. I'm the Director for Industry Solutions for Manufacturing for HiveMQ, and I have an esteemed colleague, Kelly Watt. Kelly, please introduce yourself.
Hi, my name is Kelly Watt. I'm a digital twin consultant and actually a partner with MQTT with HiveMQ on some active projects that we're working on together with.
Awesome. Thank you. And so what we're going to do is we're going to basically talk about digital twins and what sort of use cases it has. What is a digital twin in the first place? What sort of use cases it has, how it has influenced so many different industries. We'll kind of like go through like the digital twin maturity model. We'll come back and talk about like data management that enables the digital twin. And then we'll talk about a key use case for a digital twin with a common customer between us. And then we'll try to demonstrate a digital twin application along with like a data enabler that helps out the digital twin. With that said, I'll first hand it over to Kelly to take us through a few slides that talks about the digital twin experience. So Kelly, take it away.
Great. Yeah, I think it's good to level set with some of the terminology because we hear these terms used: digital factory, industry 4.0, unified namespace, digital twin. It gets really confusing how we define these terms and what the main objective is. I think the very first point that we need to make and understand is that all of these methods seek to have a business outcome to create value. It is not just to implement technology for the purpose of implementing technology. And in this transformation, towards the digital factory, the core components here are, removing paper from the process, removing the human error and the time it takes to communicate information through paper processes. And then to bring equipment to a point where equipment can talk to each other through message brokers and through automation and through active control. And that we need to do this in real time and synchronously, because if data is not jiving at the right times, we can have a lot of problems, or we can misread data, that sort of things. And we're going to gather a lot of data, more and more data, so we have to have better ways to analyze and go through that data, which we have some great tools today to be able to do. So next slide there. So on the Industry 4.0, we're enabling the digital factory, and we're doing that by bringing in real-time information so that we can run rules, run analysis to do predictive, and get to predictive outcomes and use autonomous operations and control. And at the times this can increase our revenue streams, whether it be delivering better quality, delivering better throughput on a manufacturing line, or it can build actually completely new revenue streams that we haven't seen because of the quality that we're creating data. And then who are the stakeholders that might be able to repurpose that data, reuse that data? So it really is a transformation in how we do business, and the reliance on data and the ability to get data rapidly in real time and then contextualize that data with other pieces of data that tell us the whole story. And that's the core point. The core point here is to bring in all these isolated pieces of data to a common picture where we can then make good decisions.
Yep.
So on the process of how we implement, the Industry 4.0, we're going to first need to connect and collect all the data, normalize data. One of the projects we're working on with Hive is, we had a ton of different 5 control systems, lots of different protocols, data being delivered in different frequencies. How do we bring that all together, normalize it, create a common schema that we can then run analytics on, be able to store that data in a common place so that we can look at the historical and the real time together. And adding those layers of of intelligence over that data is going to be really critical. But you know, the outputs that we're looking for on the manufacturing side is increased performance, making sure our machine is available and operating, and they have that uptime performance, and we have the quality that we're expected. So those are critical things to consider on the manufacturing side. So what are some core components that comprise a digital twin? This is going to be different for almost every customer based on the types of data and the maturity that you're at. So some of the things that we can look at are a virtual model that we are creating to reflect the physical world. That could be a building information model. It could even be a simple SCADA system that visually can understand how a system relates to other assets and that sort of thing, right? It could be an HVAC system, electrical system. It could be a production line, a data center. So we can decide what we're creating. We want to create a composable digital twin like Lego blocks that we can start to fit these things together, but we don't have to boil the ocean and do it all at once. So part of it is a visualization layer. Part of it is bringing in real-time data from sensors. And then part of it is be able to do analysis on that data, whether it be health monitoring, energy outputs, looking at set point schedules, sequence of operations, this sort of thing, so we can understand and identify issues. And we will want to layer on certain types of artificial intelligence or machine learning models, if possible, if appropriate. And then we also have the abilities to bring this data to the cloud safely, encrypted, especially if the data is brought to the cloud for, even just a one-way communication for observation and monitoring, whereas we may want to leave some of the active controls at the edge. So we've got a lot of freedom here, but we need to architect something that's safe. Next slide. So this is actually a picture I've taken on site with a customer, and it helps to kind of illustrate the challenges we have where we have business problems, and you can see all the as-built drawings here. It's a water system where we're identifying isolation valves and understanding, it's okay to get real-time data, but if I still need to go to an as-built and try to figure out what am I isolating, where is it, who's going to impact, then we don't have the full story. So what's different from a topic we're going to talk about later in the webinar, related to unified namespace and getting data centralized and organized and synchronized, it's also with a digital twin is to be able to give a spatial context. And we don't need to go crazy with the spatial context. You don't have to have the most detailed 3D model or gaming tool to be able to get the outcomes you're looking for. Sometimes, as I mentioned, a SCADA system, a GIS layer can deliver the value you need. But really, that spatial context is really important when you have real-time decision process, not only to see where and what you're impacting, but also the other things that may be related that you didn't think about that can be displayed in the same interface. Next slide. And I got a kind of a good example of a visualization that shows this. This is using Unreal Engine, but it does demonstrate both a data center and HVAC equipment in a visual way where we can peel apart the walls. All of the system information is streaming data using MQTT. Actually, this vendor standardized on MQTT, which I really like. So you can see every time we're putting on a rack here, we're seeing real-time data, whether it be temperature or other types of elements that are being monitored. And then on the back end, we have some analytics that will produce some predictive insights and things of that nature. So you can see how quickly we can navigate a space in the virtual world, see how it's operating, even how it's physically performing visually without having to physically go in the field. And then if we are going to physically go in the field, what is my best route to get there? What am I going to deal with from an environment perspective? Do I need a boom lift that I'm going to have to get up high to address something? So all those elements that as humans, we physically go to the real world so we can understand that, we can be able to gain that out with the twin. And that's kind of the promise of what a twin offers. Whereas just crunching data and just seeing data in controls platform can't really offer you alone. It gives you the window, it gives you the kind of the decision that you need to make, but providing that visual interface really takes that to the next level. Next slide.
I'm sorry.
So again, part of the digital twin is to remain synchronous. And what does that mean? We have so much change that's ongoing, whether it be construction projects, whether it be removing and replacing assets and putting in new systems. So the continuous update of the model is really critical. So having that business process change in place or be able to work with automation tools to be able to make those rapid changes really important. We want that so we can gain the insights and we can identify issues that need to be changed and to have predictive outcomes with our twin. Next slide. So again, it is about, when we talk about twins, it's about replicating the physical world with a digital model. And we often get kind of confused what is a digital model. And I think the conversation Ravi's going to have with Unified Namespace is bringing the data together. It's really about the data. That's the most important. And then how we consume the data may be really different. If I'm in a command center and I have big screens on the wall, I want to consume data in a certain way. If I'm at my desktop, I may want to consume it in a completely different way, may want different types of information. And if I'm on the field on my phone, I need very simple data that I can interact with just on my phone. And that sort of thing is really important to think about, is the business process changes that are going to have to be put in place. We can build real-time messaging, we can build unified data, we can build these visualization interfaces. But we haven't thought through the business process changes, the people that are going to interact and how that's going to change the way they do business, or if we still have paper in the process, like the earlier work orders that you saw in the picture, that we're taking a digital system and printing it and using paper and writing notes. Those kind of things can really undermine a program. So we've got to be careful with that. Next slide. And, depends on what you want to use this information for. So we have another project in Latin America where a fish processing plant wants to game out their investments before they make them. So it's about, okay, well, I want to take this piece of machinery, I want to place it in the plant, I want to see how that's going to interact. I want to see the full production line and logistics. What is the outcome if I make this business change? What are we looking at from managing the operation of people in that environment? So certain sensors like LiDAR and cameras can measure human behavior. Spatial computing can measure that human behavior. Should we offset the human with a robotic? Are we going to save safety or improve performance by doing so? So being able to game that out in a digital world is super, super valuable, so that you don't make those mistakes. You implement something that's $1 million piece of mechanical equipment or machinery or robot, and it's not getting the outcome that you're getting or that you're expecting, then you're going to be in a little bit of trouble. And that's one nice thing I like about the Hive Broker too, is you can put through synthetic data and you can simulate an environment, stress test something before you actually put it out in the real. Next slide. So, kind of encapsulating some of this conversation, the importance of a digital twin is to bring in spatial, static, historical, and live data, but to be able to unify that data into a common data environment or common data model, or what we're going to talk a little bit about, unified namespace, so that that information is synchronous, it's possibly in a single payload, and it can be looked at to understand a snapshot in time or a snapshot historically in time, so that you can understand the true impact of what's going on at your organization. We also need to provide context, and context is really important. And that can include, anything from a semantic relationship or ontology, so that even the hierarchy of systems, so we can understand, how one thing impacts another, and that sort of downstream impact or the upstream impact of something that we're seeing. If we look at things in a silo, I see a single sensor, I see a single temperature, it doesn't give me the operating picture. I really don't understand kind of what is really going on, right? And then again, as we talked about previously, is a visualization interface is delivering the right amount of data, not too much, not too little, to the right people in the format they need to do their decisions. And understand that if we're going through this effort to construct something like this, it has to be significant to the operator, and it must move the needle and impact their business process, their change. How is it making their life easier? How do they deliver a better quality outcome, quicker outcome? How do we avoid mistakes? How do we improve safety? All of those elements, what is the use case going to drive in terms of value downstream of the worker level or whomever is going to be using the tool? And all of our data customers have different needs. So the use case may, kind of be deployed for a specific need, a specific user, but there could be 3 or 4 different ways we use that same data, but it needs to be consumed a little different, and we're doing things different with that data. Next slide. So it's a journey. All of these projects are journeys. It starts with leadership buy-in and understanding that the world has changed. We are not going to have 30, 40-year people in our organization that have all the institutional knowledge, that can walk through a plant, hear it, smell it, see it, understand it, react to it. We really need to prepare for the future. We need to have that institutional knowledge baked into digital processes with recommendations and with tools to be able to help us crunch data quickly and to be able to get to good decisions. So the starting point from this is a systems approach and a common data environment, and looking at the different data points that need to be brought together. We're looking at kind of describing the physical environment and understanding it. Then we look to kind of diagnose with adding certain elements of intelligence up to predicting outcomes, and then getting to prescribing. So understand what we are seeing, how do we react, and then get to the point where we have autonomous processes, which is the kind of end outcome, but I think a lot of companies are not quite there yet. We really need to have human involvement to train those models to a place where we're comfortable. But there are certain things that we've been doing in building automation controls and active controls for a long time that we're comfortable that they're automated. We're just going to make sure we have a check and monitor on that. Next slide. So out of these projects, what we have seen historically as a consulting company, we go in to do master planning and start to understand and look at use cases, prioritize use case, look at business systems, understand where we're going to have problems deploying, understand where we're going to have successes, where the low-hanging fruit is, defining value, financial, etc., ideating those problems, building out those use cases. All of this kind of, we can do this. Where the underpinning of failures typically happen in an organization are not foreseeing the operational impacts in the business and the human, and institutionalizing these tools. So it's really important when we get into these types of projects is to really take a couple steps back, not just to look at the interface and say, oh, I like that, I want to implement it. What kind of data can we throw at it? It's really like, this is a business problem tool. What are we going to do? Why do we need real-time data? What's going to move the needle? How are we going to see incremental value? When you're taking those approaches, you're really going to see value in these programs. And especially with the first program projects that you put in place, you have success there. It just accelerates the transformation effort. Last slide there. So as a consulting company, we typically first engage with gathering some data about business systems, understanding the quality of data, doing an analysis from a needs perspective, assessing out the different use cases that we could create value from, understanding the dependencies, the investments, the gaps to achieve those, also matching to leadership goals, financial history, outcomes, and then really kind of going through a gated process to build out the roadmaps, build out the projects, price them out, schedule them out, looking through the technology, making sure that we have something that's scalable, like Hive. We may start with, a couple thousand points, but if we want to get to mass data, we got to make sure we're picking the right tools that are going to get us there. And then to move into kind of oversight of the project if needed, and program management. And understanding that not all digital transformation efforts need to go through a digital twin. There are different use cases. If there's no need to create that visual layer, we got to make those decisions because they are costly. So we want to invest in what's going to create value. And that's really the key outcome. I'm going to hand it to Ravi now. Thanks, Ravi.
Thank you, Kelly. That's fantastic. So I really liked what Kelly talked about from a digital twin maturity model, amongst the other things that he talked about, where he talked about kind of like what is that journey of the digital twin, right? He talked about how the initial goal is to get it to predictive, and then prescriptive, and then autonomous, right? So again, all through that journey is the data, right? And as long as you have good data, then getting to autonomous and you can build a discipline around that data, you can easily get to autonomous, right? So from an industrial setup perspective, right? So we see this triangle of how data is organized, where at the bottom layer, you have the sensors and actuators, and then you have the programming logic controllers that control that. And then Kelly did mention the SCADA system, which is a supervisory access and a distributed access systems that control certain subsections of industrial environments. You have systems like MES from a manufacturing perspective that supports the manufacturing process. And then, of course, ERP, which is for ordering and managing your goods coming in and going out, the finished products going out. So typically what we call in an ISA 95 model, these things kind of like are stacked up. They are kind of like in a separate bubble, right? It was done for a specific reason, but the problem with the Industry 4.0 approach is that any of these layers need to talk to each other, right? Which means that if they're separate, then you would need like point-to-point integration between each of these layers to be able to talk to each other. That would mean a lot of customizations, a lot of throwaway code, because every system is different, the interactions are different. So you have to go into a particular factory and develop these point-to-point integrations and ensure that you can cut through all of these layers. For example, if you want the shop floor to talk to the top floor, which is the cloud, you have to go through each of these layers and go through all the security protocols of all of these different layers. And it might be a lot of work, right? And then, needless to say, if you want to establish the communication within your factory environment or industrial environments, over time, you're going to have the spaghetti architecture, because every system wants to talk to other systems in a typical client-server model, establish direct connectivity, and try to get the data out, which if you're kind of like in a small bubble, that might work. But as you try to scale up, it doesn't work at all. So you're going to have like a very inefficient use of your bandwidth, your limited connectivity that you have, and that doesn't augur well. So it doesn't really help you scale up or be highly reliable and ensure that you are able to offer your sophisticated digital twin applications. So one of the things that that we talk about is, as opposed to that spaghetti architecture that we have this publish subscribe based architecture that MQTT brings in. MQTT is a messaging protocol that started in the late 90s. It was started by IBM specifically for oil and gas, with the goal of enabling remote monitoring for remote oil wells where they don't have much connectivity, the bandwidth is limited. How the traditional methods of connectivity doesn't work. So how can you still connect while kind of like keeping up with the infrastructure? So the publish subscribe based protocol, what it does is, like, you have clients, and then when the clients have information to publish, they publish to a centralized broker, MQTT broker, like a HiveMQ, for example. And that broker then shares that information with other clients that need that information. So it's all asynchronous, it's all event driven, and the packet sizes are very small. So it's naturally lightweight and efficient. Publish subscribe, it's bidirectional, so you can enable publishers to be subscribers and vice versa. And it's all stateful, right? Because you exactly know what the state of the publisher or the subscriber is. You can have a last will and testament and things like that. So MQTT is fast becoming the de facto protocol when it comes to IoT. And HiveMQ has basically taken that MQTT, which, by the way, became open source in 2010, and we have built our solution on top of that to make it highly scalable, highly reliable, and highly secure. Because we talk about connections where you have to talk to all of these different systems, consolidate the data, and be able to bring it. So we have the HiveMQ Edge that can consolidate the data, convert that to MQTT, can do store forward as needed, because you don't have connectivity all the time. So you lose connectivity, so you have to buffer the data. And then you bring in the data to like a centralized broker where you want to do some cleansing. You want to be able to normalize and ensure that the data is the right quality. Maybe the data is in the right range, because your digital twin only needs data in this range. And also your digital twin needs real-time data. That's kind of like something that MQTT enables for you to have real-time data. And then there needs to be some dynamic changes, because your factories or your industrial subsystem keeps changing. So your twin needs to be kept up to date with that. And that's kind of like what HiveMQ and MQTT can provide, because of the publish subscribe nature. And it can also talk to various different systems. Maybe you want to build your digital twin in a particular application, and that application is not compatible with MQTT. So we can use our extensions framework, which is basically SDKs that were built off of our application, to be able to talk to all of these different systems. And we can exist on premise or also on the cloud, because we realize that our customers are not always on the cloud. They want an on-premise solution, or the customers prefer a certain cloud-based solution. And so we can support all of that. that's kind of like in a nutshell what HiveMQ provides to enable digital twin application. And this is just another reiteration of like what are the different kinds of devices that we talk to, the solutions that we employ to bring in the data, the kind of applications that we can talk to enable that you can bring all of the data together in one location, powered by MQTT. Some of the key industries that we focus on, connected cars, manufacturing, transportation and logistics, and energy. We have many customers in all of these different verticals. And now let's talk about unified namespace. So we talked about MQTT and what it does. Unified namespace is a framework that uses MQTT, and it basically builds a common data infrastructure. So we talked about like different subsystems within your industrial environments, and these subsystems can coexist in different locations within your factory or your data center or other HVAC systems and other things, right? So each of these are publishing data, and each of these have a particular way of organizing the data. So, but then like if you want to be able to do digital twins, you need data from like 10 different sources, and you want to kind of like have a common way of looking at the data. That's what this common infrastructure allows you to do. It brings in data from control systems, from operating systems, other information systems, applications, other locations within your business, and it is able to build that common data infrastructure, which is lightweight, which is open architecture based because it's MQTT, and then it's also able to do report by exceptions. And that's the foundation for allowing you to be able to have the data ready for applications like digital twins and AI, which could be on top of digital twins, to be able to take the data and get to that true autonomy or prescriptive and preemptive. So what are the different the aspects of the unified namespace, right? So at the core, you have like your plant floor. You could also have like different other kind of files that could come in. You could have a database. So the core thing about like the unified namespace is that data model. So Kelly talked about like having that common data model. The unified namespace can help you create that data model, which creates that contextualized data, which normalizes data, it transforms the data in some cases. Maybe you don't need the data in certain formats. You want all of your data to be, say, for example, in a JSON format or XML format. That's what it's able to do. It's able to transform the data and then basically bring it into a HiveMQ broker. And then it becomes the unified namespace, which can then help you visualize all of your data, events, alarms, and other key things, parameters about your enterprise in a single location. And that data can then be shared and then can be used to build your digital twins or build your AI applications and things like that. So going back to that other diagram that we talked about where we have individual layers, juxtapose that to like a unified namespace, basically demonstrating how a unified namespace enables you to bring all of these different layers together and create that common data model. So you might want to have a unified namespace just for your shop floor, because that's kind of like the area that you want to be, or the line that you want to be in, and that's enough for you. But then there is a need to bring that to the site level, because there might be other folks within your industrial environment that want to look at like the data from a site level perspective. And then you want to, there are other individuals or aspects of your organization that want to see the data at an enterprise location. Maybe you want to build digital twins at each of these different locations. So the various unified namespaces allows you to do that. And then this is kind of like the typical way a ISA 95 model is seen as enterprise site area, production line, and work cell. And so a unified namespace helps you take this model and then basically map it to namespaces and then bring in data from other locations and create that common data model. And a typical kind of like way unified namespace is organized here, you have like a dairy farm, which has different sections. So packaging is one of the disciplines that it has. Underneath that, you could have like a line, you could have a cell, and you might want to have different parameters, but you also want to look at KPIs. You want to look at like certain other information, maybe alarms and set points. So again, this is kind of like helps you visualize all of that and gives you like a red, amber, green of what the current state of your enterprise is, so that if there is any issue, you'll be forewarned immediately, and then that allows you to go into that particular system and look at what is happening, if you will, right? For example, if your digital twin is not performing, you can go to the unified namespace and look at why the data is not flowing, which system is having a problem. So it'll immediately help you get to the root cause of your problem and debug it. And again, this is another way to look at the unified namespace on how an MQTT broker can bring in the data from different locations. And not all of these devices, for example, need to be IoT ready.
Wait for a second, we can kind of maybe skip a slide here and jump
Yeah,
into the demo here.
Kelly, maybe while we get Ravi back, I know that there's quite a few in the Q&A. Are there any questions that you'd like to answer now?
Sure. I can. Let's start to dive into some of the questions while we're waiting here. So, what are the resources and time in creating a digital twin for a factory line, and can it be, say, weeks or months or even more? So I guess it depends on first how you're going to define what your digital twin is. What are your components? What are your data sources that you need? And what is that physical use case? So we usually build agile projects, could be 6 weeks to 3 months on a small project to be able to deploy something. There's always going to be elements of integration that take time and cost, but what we do through that process of evaluation is first to map that out before you get started. So it will really depend, and I would say that the most important thing is to go through that evaluation first and really look at what are the top 10 things, and from those top 10, where would you want to get started, right?
I'm
Ravi, we got you back now?
Yes,
No
I'm terribly sorry. I don't know where we left off. What did we
you were explaining unified namespace. I just chose to dive into one question that we had. So if you want to pull up the deck again, we can continue.
Yes, please.
And I'll answer one last question related to animation and simulation. So animation is really animating physical data that we have in hand. Simulation, we're going to run different scenarios. It can be synthetic data. So there's some differences. We're trying to game out an outcome with simulated data. Animating is just, we're showing a forklift in real time. We're showing a certain flow. We're showing something that is active based on data points. So that's the way I kind of, in very general terms, describe those things. And then what do we got here? Can a digital twin be too complex so it will require separate IT teams and support it through the life cycle? And depending on the organization, it absolutely could be. But what we can do is build what we call composable digital twins, which are, very specific fit for purpose twins that are building blocks. So it doesn't start to be too over complex out of the gate. But Ravi's got his slide back up here. So why don't we dive back into a couple of use cases that we're working on together.
Please
and then we'll do our best to get to most of the questions after that.
So go ahead, Kelly. You want to start talking about DFW?
Okay, so we have a 6-7 projects that we're doing right now, all that touch IoT. And really one of the challenges we had first is to really normalize the data from 5 different control platforms and to be able to get a common schema, data flowing in real time. And the Hive team, we spent about 6 months looking at solutions, grappling with ways to deal with data. And one of the key objectives was, let's remove the vendor from being completely in control of our data. So having a node-based broker to be able to communicate data from end device to a software platform owned by a vendor, that was a key outcome that we're looking for, that we were able to achieve. So one of the projects is a water system. So you have about 200 miles of underground pipe for potable water, pressurized water system, with very limited monitoring. There's certainly monitoring at certain points, but with it being over 50 years old, we do have leaks. It's hard to detect where those physical leaks are located and how long they're leaking. So we've designed out a district metering strategy. So 6 different districts where we're going to measure bidirectional high accurate flow in and out of those districts, with different sub-districts with pressure. So again, we have a lot of IoT data, but we need to be able to visualize this in the twin. We need to be able to run some analytics so we know what is the consumption. DFW acts like a city. So we have over 800 consumers of our water, which are billed, but only billed by 1,000 gallons. So taking the 1,000 gallon down to half a gallon, measuring it in real time was really critical. Our payloads in the past were every 6 hours, which is completely fine for billing, completely inadequate for leak detection and trying to understand how much we're consuming in real time. So moving to the real time, be able to communicate the data remotely from the field where we don't have power, we don't have a stable, Ethernet connection or something like that. We'll be able to push that directly to Hive, fully encrypted with our preferred schema, using a signal flare box, which really pleased to find out that was native with MQTT and SparkB, which is a schema we're using, and push that down safely to our network where we can start to consume and then renormalize the data for our SCADA system. And then even some of the control valves that will be doing two-way communication will be able to push back and close off remote valves as desired. So we're going to see some pretty significant outcomes out of this. When we have a leak that's close to a runway or a major throughput, a highway system or whatnot, that all of these things exist at the airport. It's not necessarily the cost of water, is the cost of that disruption can be very significant. So hopefully we'll see some great outcomes, but got a good architecture, a good first rollout here on this one.
Yeah, and this is another key point that I wanted to reiterate, that you talked about remote locations and not having enough connectivity and bandwidth. And that's kind of like where MQTT really comes in, because it is event driven. It's very, very small payload, and it can work with very limited bandwidth and very less connectivity. So
and less power too, so we can utilize solar and things of that nature, not have to conduit power from 1,000 feet away. So that really reduces the cost overall project and makes it quite feasible too.
Awesome. Awesome. So on that note, why don't we just jump into a demo? I think the demo is also kind of like based on the DFW system. So maybe we can just jump into that.
Sure.
Yeah.
So this is a window into our twin where we have various facilities that are at different life cycles of the twinning process. There are core components that we will have within the twin. So this is our central utility plant with the building information model. So we'd be able to isolate, a specific chiller in this case. We can drill into the chiller. We have our CMMS information, our naming and attribution. We have documents related to, whether it be an ONAM or a startup procedure, et cetera. So those documents are supporting information that we need to fix, maintain that equipment. We've also been really big on collecting reality capture so that we have better visuals, current conditions, things like the color of pipes, the flow of water, things like that. And here's our data that's being streamed from Hive. So we have telemetry data pulling in. We have the relationship between that data. And then we have a rules engine where we're running predictive insights and look certain models so that we can get to understanding where our failures may be and we can address those quickly.
Awesome. Awesome. Let me just on the back of that, let me just jump into a quick demo on our platform real quick, and then show how we enable some of those experiences, right? So this could be like a typical an architecture where you have like different sections, maybe a chiller or other equipment that is putting out data in a certain format that needs to be brought in because you want to combine that with maybe like a document data and to kind of like show that big picture. And this is where our edge solution kind of like comes in and then does the data conversion from all of these different formats into MQTT. It can do the aliasing of the UNS. I think we talked about unified namespace as that single source of truth, which enables you to kind of like have a centralized repository of all of the data that you have. But you can actually build multiple UNSs, right? You could build potentially, like if you look at this multi-site flow, you could build a UNS just at this section of your industrial location. Or you can build it one layer up or one layer up. Or it's kind of like all like stacked up, and what we call federation of our brokers to kind of like bring in data from different locations. But each of the locations can have its own kind of contextualization of the data, because you want to have that separation because you have a complex organization. So it's all about like bringing the data. But it's not just about like bringing the data. It's about bringing the right data, contextualizing it, converting it to a format that makes sense for what you're trying to do, and then continuously doing that, because it's not just you do it one time and you're done. You have to keep going back and making sure that that data is real time, it's contextualized, it's ready to go. Any new data or any new subsystem that you might add to your factory floor or your industrial setup, you want to update the twin or you want to update your end system. So again, this allows you a combination of MQTT, SparkB, and unified namespace allows you to be able to do that. So you can visualize your unified namespace as a tree structure, going down to like your telemetry data or whatever other maintenance or other data, going back to where it came from. Or you can have an explorer view of your UNS data. Hey, these are the different locations. These are the different processes that happen within those locations. And I want to drill down into like this ERP system, which is there on this, and look at the ordered quantity, for example. And this is what I see. And in some cases, it could be red. Maybe there is some issue with that particular order. So that would allow you to like immediately take action, going to that particular ERP system and see what's happening. So a unified namespace, think of it as like an index card, a library index card of all of the books that you have within your library or within your enterprise, and then making sure that you're able to know the absolute up-to-date status of all of the things that are going on within your enterprise, and then allowing you to see what alarms are happening, what is critical, what is not critical, and what action you basically need to take right at this point for you to be able to do that. And then we have this other cool integration with the bot, because obviously like generative AI is the way we are going. So we have a copilot with Google where we have integrated like the Google Gemini with the data that we're providing. So you as like a technician can ask questions about like things that are happening in your industrial location or factory. Hey, tell me all the OE of the welding area, or tell me like all the rejected quantities of items in this particular location. What's the average temperature of my robots? Things like that. So before I come into my shift, I know all of this and I can use that. So that is the quick demo of what we have. Maybe at this point, let's open it out to questions. I know, Kelly, you already started looking at that, so I'm going to
Yeah, we
stop
got a lot of
share.
questions here, so
Let's go for it.
that's always great. Always appreciate the feedback. So why don't we tackle a few of these? Ravi, do you want to pick out a few that you want to handle, and I can do the same?
I like this. What about the historical data which might need to project on digital twin? Does UNS hold the historical information from machines and processes? I can start off, and then Kelly, you can add as well, right? So typically, UNS is a like a screenshot or like the latest information, but there is a way you can kind of like build in history as well using a UNS. Obviously, it juxtaposing that with a historian, where you're able to historize some of the information and send it to a historian and bring it back as needed. You can absolutely get like the history as well through UNS.
Yeah, and I think if you look at this from a digital twin perspective, the promise of twin is the historical, the current, and the what ifs in the future from a simulation perspective. So be able to look back in time and use historical data to validate certain issues. So that information needs to be available within the framework of a digital twin project. So again, the unified name space is a component. There are other components that would feed into a twin. Historical being a key part of that. Yeah.
Great.
Want to grab another one?
Yes, please. A question on the placement of the HiveMQ server. Are you installing it on a DMZ or an office environment? I think it all depends, right? Depending on, like, for example, if you're talking about an edge environment, that typically is in your DMZ, or it's sitting right next to your machine that is putting out the data. And you might have many of these edge locations or edge gateways collecting information. Whereas like the centralized broker is typically on your enterprise side of things within like an enterprise setting with any of your other IT systems, if you will. And there is a way to bridge the data between these remote edge-based brokers to your centralized location.
I'm going to take an anonymous question. It has to do with, how challenging it is to get 3D models and BIM models. And I think that's one of the difficulties in the term of digital twin. We usually visualize something 3D and that becomes a starting point. Well, we can't start until we have that. And I don't always agree with that. Sometimes the data is something that we can get going forward first and execute on. But to answer the question, yes, getting the 3D information from your buildings is far, far easier than it has ever been in the past. I used to be the director of a major LiDAR company, and even just the time I was there between the starting point and the end, the ability to use mobile LiDAR, to be able to use 360 imagery, to be able to collect current as-built conditions is far easier than it has been in the past. And same with the rapid prototyping on the modeling itself, and then converting existing construction models into gaming interfaces like the demonstration we showed today. There's still an inherent cost, but the value proposition is massive, especially when we have such large costs to maintain complex facilities. And when you have complex facilities, major factories, airports, and things of that nature, keeping track of everything is really, really important. And to be able to do that in file structures can be very daunting, right? So to be able to walk into a room virtually, point at something and extract all the information, whether it be real time, whether it be historical, CMMS, whatever's in your twin, that's a really powerful way of re-engineering how we organize information.
Yeah, yeah. Maybe I'll take a question from Lala Vishwanath. He has 3 questions. So some of the questions pertain to both of us. Some of it is like just to you and me. All right. The first question is, does every individual unified namespace have its own MQTT broker instance? Typically, like when the unified namespace is built in with an MQTT broker. So I would say yes. Some of it could be just the edge gateway. Some of it could be like a broker. But again, it all depends on how you architect your system. But typically that's the case. Is a twin dependent on the MQTT protocol? The answer is no. I mean, MQTT enables the twins, but there are other ways to obviously build the twin. As Kelly mentioned, the reason why you use MQTT is that in a lot of cases, right, you have to pull in data from like limited bandwidth scenarios or like very low connectivity. So MQTT definitely is a big enabler for a twin, but it's not absolutely dependent on it.
Yeah, it just simplifies the complexity of all these different business systems and protocols. And also is a lightweight. So when we looked at BACnet, which is common in the HVAC world, to MQTT with the SparkB, which is a schema and a compression that's over top, we're 1/10 of the data size. So when you start to stream real-time data, and you can see that kind of impact when you're going to the cloud, it also has a significant cost savings on how you're going to be able to manage this over time. So those are considerations to think about.
Yeah. There's also a third question. What are the ideas to address digital twin synchronization problems? These can be caused by network delays and inaccuracies. You're laughing. Go ahead.
Yeah, and I think one of the beautiful things about the MQTT is the caching. So we have iterative communication at times, but it still has that last delivery and a death record and a birth record, so that we know if something's offline or re-engaged it's online again. But even kind of beyond the IoT is the change management, and that is the most daunting task for the digital twin is this promise that it needs to stay synchronous. Well, what does synchronous mean, right? What are the ongoing changes that happen in an organization? Some of those are business process changes that come from a CMMS that are not always real time, and we're always trying to catch up with, information that's logged. So really eliminating paper, getting to digital processes, having automation where, even drop downs, things like this, that you create quality data should be a big focus. And then really have a change management process. It's really, really important is to be able to make sure that you're documenting change throughout, time, because otherwise you'll make, decisions based on erroneous data, right? So that's really problematic.
Yeah, a lot of questions to keep up. So I'm going to take this. What modeling strategy do you take for your digital twins? Typically, are they first principle models, regression models? How do you deal with the challenge of maintaining models with change date over time and different scenarios?
Wow. Use case driven, right, Ravi? Yeah. I mean, it's really the outcomes that you're trying to drive. It really is depending on what you want to get out of the twin. What are the outcomes?
Yeah. This is an interesting question. Can it make sense to jump into a digital twin technology for temporary projects? Like I have a music festival, which lasts not for a long time, just for a week. Are there any resources and time savings approaches to such temporary digital twins? And can it still have commercial success? Do you have any projects in your experience?
So I think you can visualize like people and layout and design. I think there's some really good use cases for simulating those physical environments. Now, I don't know if you call it a twin. We get into some semantics of what it's called and what you're trying to do. But I think if you just look at the components of the problem that you're trying to solve, how do you capture the visual physical environment? You have satellite imagery, fixed wing drones can capture a lot of topology really quickly and understand a physical environment. And then from there, you can bring in real time, things like movement of people and vehicles. So there's a lot that can be done from a simulation perspective. You might call it a simulation, not a twin, because a twin is really kind of replicating the real-time world in real time. Simulation's a component. But I think, just in terms of these interfaces and working with data, there are a lot of business outcomes that we can get from working with these different types of data components. Similar kind of strategies too, and how data flows. Yeah.
So you're basically saying that you can create a twin of anything, because there's a question on like, hey, can I have a twin of a vehicle? The answer is yes, right? Yeah. Absolutely.
Yeah, and with GPS, here's actually a really fascinating use case that we're looking at right now, and it's there is a crowdsourcing from the sensors that are on physical vehicles. So the company has an agreement with Volkswagen, and Volkswagen vehicles are driving all over the airport all the time, and they're collecting data. That data is then sold to a third party that is visualizing the data in terms of road conditions. So the friction coefficient on the ground, potholes, things of that nature, can light up in real time every day from the subscription of that data source. And now we don't have to do physical inspections out there. It's not something we've implemented right yet, but it's a really fascinating way that we can take an outside data source to solve a problem and use a basic GIS interface and not really have to build anything that's complex, but we have real-time data driving decisions on how we maintain it and how do we be more effective with road maintenance. So I think there's a lot of interesting things from that perspective.
Absolutely, absolutely. So one of the question, we are considering creating a digital twin for our 4,400 public transport vehicles using MQTT. Is that a good idea?
Depends on what you're trying to get from it, right? So, I mean, are you trying to monitor the most efficient movement of the vehicles with GPS? I know there was a case study. It was done by FedEx or DHL. Sorry, I don't remember what it was. And they made all their vehicles turn right and not left. And that one use case saved them millions of dollars because of routing. So there could be wayfinding routing use cases. You could be looking at safety. So I think, you got to always look at, well, what is the business problem we're not here to create a digital twin. First, we're trying to solve a business problem. And that is the digital twin, or is unified namespace, or just broker messaging. What is going to solve that problem, and then looking at it from that way. So always look at from the business problem first.
Yeah, for sure. So this one is for me. You mentioned JSON and XML as a potential data format in the process. How common is it to see non-binary data formats mixed in, given how low performance they can be? Look, I mean, I think this is kind of like some of the challenges that we have in the industry, right? Different data sources put out like data in different formats, while JSON is pretty common because it's human readable. XML is pretty common. You also see other models like you said, a non-binary model like Google Protobuf and others, right? So what we are trying to do is through our platform, we are trying to bet on a few that we know are used 80% of the case. For example, we are able to convert the Google Protobuf into JSON to allow that common way of looking at data, if you will. But then there are others that are out there that can also be converted. So the goal is to try to understand like what best works for you, and then try to bring it in the format that makes most sense for you.
There's one here about standardization to avoid name conflicts with multi-site scenarios. If we're looking from an IoT perspective, I think the unified namespace using the SmartB schema is a really smart way to approach it, because location name is part of the schema, and it eliminates that potential challenge. You can add certain other location-specific metrics within your schema, so you can avoid some of that. But it's really important to think scale, right? So you have to think about what is the future state going to look like, how I'm going to manage this data, so we can avoid those challenges. And for us, being able to normalize that data, apply that schema, even if we had bad data in the past, now it's been transformed into something that's really useful for us in the future.
Yeah. So another question is, why do we need real-time data to run simulations? What if scenarios? Can you please mention a use case for this? What you use real-time data and not a snapshot from a past? For this, there is no need to collect data in real time. So basically for simulations, Kelly.
Well, I mean, you do not need real-time data for simulations.
Okay.
I would say it's a use case driven scenario. So if I'm doing simulations with something that's fast moving, vehicles, people, aircrafts, things of that nature, we're going to need to aggregate a lot more data. And nothing is really, real time with a simulation. A simulation is something we construct. It's artificial based on data that we're feeding to the system, right? Whereas real-time data is something that we're collecting from a device that is monitoring something, and it is basically displaying the physical behavior of that end device. So, the two things that I look at, simulation data could be historical data. It could be something we're changing attributes on that data to see, well, what if it performed this way? So there are different ways and different simulation models that you can run, but that's synthetic data typically, right? It's created data.
Great. Okay, so this one is what are the digital twin solution made of for each of the case studies on top of the UNS provided by HiveMQ, Azure, AWS? I mean, I guess like where does it reside, right? Azure or AWS, I would say it can reside anywhere, right? It just depends on what you...
It depends on your IT department and your appetite for cloud versus edge, and really what your business needs are. Especially the bigger the organization, the cloud offers so much benefits, also offers risk, right? And that's one nice thing about Hive is that we're implementing, our high-level encryption layers so that we can protect the data in transit until its destination. So that's a question you just need to have internally, and also to look at your business system. So if your systems are at the edge and you're trying to bring in a cloud interface, sometimes that doesn't always work so well. If you have a lot of cloud systems, naturally staying in the cloud can be a helpful way to approach the problem.
Yeah. Here's an interesting question. How enterprise IT systems like ERP, MES integrate with UNS? Is it required to set up an MQTT client for these systems to publish data to UNS? The short answer is yes. I think that is the easiest and most elegant way to get the data from these remote IT systems into the unified namespace. But you can also write like extensions. Like for example, we have extensions that talk to databases. We have extensions that talk to streaming analytics platform that don't necessarily understand MQTT, but want to exchange information with MQTT. For example, if you want to do Kafka streaming and Kafka wants IIoT data, there is an extension from HiveMQ that goes into Kafka, so you get best of both worlds. So there is that way to do it as well. But typically, like having a client is great.
Right.
All right. Are digital twins only useful for existing systems plans, or is there a way to use it in the planning phase for a new plant, for example?
Yeah, and I brought that example up with the fish processing plant in Latin America, where we want to implement new equipment. So we have a physical environment. We're removing a piece of equipment. We're adding a new piece of equipment. We're running a simulation on how that's going to impact, things like robotics, adding robotics. What is the difference between a human versus a robot? So I think there's a lot of simulation or scenario-based learning that can be done in the plan side of the house. Also, a lot of simulation is done in early construction on energy modeling and things of that nature. Electrical modeling is another good one. Excellent example where there are good products like DTAP that are bringing in loads and whatnot, be able to change some of those variables and run and rerun those scenarios so that we understand outcomes before we physically implement those in the real environment.
Yeah. The questions keep pouring in, by the way. Maybe we'll just take one more last question, and then for the rest of the questions, we might have to just give offline responses, because this will be absolutely...
I think we should send the answers after the webinar. If people spend the time to create a question, we want to make sure we answer your question.
Absolutely.
I love all the questions. It's great that we're getting a lot of conversation here.
Okay. One last question. What are the key advantages of digital twin over data analytics? Once data analytics source is historical and then digital twin is real time, is that the big advantage?
No. So I think there's different ways we define digital twin. We got to be very careful there first, right? So what is the scope of the twin? What is the promise, and what are the components, right? So analytics are a part of a twin. It's a component of a twin. It's part of what we'd be doing with broker technology downstream as well. But one of the core things that stands out from some of the other terms that we define here is the spatial context. Where is the physical message coming from, and how does it relate? So does it relate to an asset, a system? So I think that the spatial component on the twin is what often kind of defines it a little bit differently. But that'd be my kind of main comment there. Go ahead, Ravi.
Yeah. Yeah, you know what? I think we're up on the hour. I think we should probably stop here. Anadulia, back to you. I think we can kind of like wrap this up.
Yes, thank you so much to everyone that joined us today. If we didn't get to your questions, we will follow up with you via email. Again, this session was recorded. We will send you the recording, and a big thank you to our speakers, Ravi and Kelly, for today's presentation.
Thank you. Bye-bye.
See you next time.
Thanks.